What's good, YouTube? Donald here. In this video, we're going to do number 366, find leaves of a binary tree. So given the root of a binary tree, collect the tree's nodes as if you're doing this. So you collect all the leaves nodes, we yeet the leaves nodes from the tree, and repeat until the tree is empty. So from here, basically what we're doing here is we're taking out 4, 5, and 3, taking it out, putting it in our array. Then we take out 2, as seen here, and then take out 1. So basically what we want to do is, since we want to go to the bottom level first, we want to be using a depth first search, right? So if you guys don't know, I've done a couple of problems on depth first search, but overall what you want to do is you want to have your base case, you want to have your you want to traverse the left-hand side and the right-hand side, and you also have some sort of a condition. So what's a condition here? Well, what we want to do is we want to go from the bottom to the top. So we want to take all of these and we want to append them to a final array, and then we take one step up, we append those and take one step up, so we're taking a bottom-up approach, right? So let's also do the code now, right? So what we want to do first is we want to initialize the answer, right? And the second thing that we want to do is we want to define our depth first search, right? So I'm going to define depth first search, and what we want to do here is we really want to find out what the height is, right? So what do I mean by the height? Well, the height is basically, if we were to start at the base here, that's going to be a height of 0, right? And what we're going to do is we're going to take our height and we're going to add it to our array here, right? And then we're going to move up. We're going to move up to a height of 1 here, and then we're going to add this to the array here, just like it's shown here. And then we move on to height of 3, and we're going to add that to the array, right? So let's do that in code. So the first thing we need to do is we need to define what our base case is, right? So base case is if not current node. What we're going to do is we're going to return -1, right? So basically, I'll explain the base case in a bit, and it's going to make more sense as we go deeper in the code here, right? So what I'm going to do is I always like to define a left is equal to our recursive call to the left-hand side of the node, right? And I also like to define a right to equal to the recursive call of the node to the right. So now what we need to do is we need to calculate the height. Now how are we going to do that? We know, like for example, this one has a children here and also children here, right? So it makes more sense that we need to go down the left hand side first, right, before we go to the right hand side, right? That's what depth first search is all about. So how do we do that? Well, let's define our height to be the max of the left and the right plus 1, right? So if we were at the root node, basically what this would do is it would take left and right. In this case, it would pretty much be the same thing. So it would go towards the left-hand side. And then if we look to the left-hand side compared to the right-hand side, we see that the left-hand side contains children. The right-hand side doesn't. So we're going down the left-hand side again, right? And then we're using this -1. So if we notice that a node is null, what we're going to do is we're going to go use -1 to go back, because +1 minus 1 is obviously going to equal 0, right? So that's the logic behind that, right? So now what we need to do is now that we have the general format of the depth first search, and also the last thing we're going to do is obviously we're going to return the height, because that's what we're trying to look for here, right? And then we're going to call the function at the end. So actually, let's do that. So we're going to do a depth first search using the root, and we're going to return the answer, right? Now that we have kind of the basis here, now all there's really left to do is to define exactly how do we find the height and how do we get our answer, right? Well, if we kind of think logically, right? Well, we would want to append the height over here into our input array, considering that we're down at the end here, and that would be pretty simple. But think about it. Our answer here hasn't been really set up quite yet, so we do need to make sure that we're setting that up, right? So as we're going down, as we're at the appropriate height, so if we were at height of 0 here, which would be 4, 5, and 3, what we would need to do is we would need to set up an empty array if it doesn't exist, right? And then we add values, otherwise we're going to get a list error, right? So what do I mean by that? Let's code it up so it makes a little bit more sense. So we're going to have, if the length of the answer is less than or equal to the height, what we're going to do is we're going to add an empty string, I guess you could call it, into our array so that we can add our values right after that. So we're going to append the answer, and all we're going to do is we're going to append an empty string. So basically what's happening here is if I had an empty string here, what I would do is add another empty string here, and then I proceed to add my values, say 4, 5, and 3, 4, 5, and 3, and then I go back up here, right? And then say I add another empty string like this, and then I would add my 2, and then I would go back again as I start to traverse up the array, and then I add empty, and then 1. So that's kind of how it works. I hope that was clear. So the last thing to do is we're going to append the answer, and we're going to simply append the current node.value. And if I get everything right, that should work. Type error is a non-valid value. Yes. Almost forgot. Need to append to the height so that we're inside of the bracket, right? Let's have a look. And if we click submit, we are successful. So this is an O of N solution, pretty efficient. So if you guys enjoyed the video, don't forget to hit like, comment, subscribe, and I'll see you next time.